Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 17, 2025, just yesterday. It replaces the usual autoregressive drafter in speculative decoding with the Diffusion large language model drafter, and it reports a 5.54x speedup on human eval with QN330 BA3B versus 2.41x for Eagle 3. The paper is titled, Deer, Draft with Diffusion, Verify with Autoregressive Models. Alright, as we go, the key idea is how diffusion drafting enables much longer accepted draft segments without breaking correctness. Figure 1 makes the practical claim really concrete, because it shows diffusion drafting translates into emphasized real speed and longer accepted drafts. Acceptance length, written as tau, means how many drafted tokens the verifier keeps before it has to intervene. The left chart reports speedup, where Deer stays higher than Eagle 3 across the QN3 family. The right chart reports tau and Deer again leads, especially on the largest model. Figure 2 explains why diffusion drafting can keep longer chunks because it avoids the left-to-right error snowball that hurts autoregressive drafters. The left panel sketches an acceptance region, where a dependence-based draft trajectory curves away from the target path as small mistakes compound, while an independent-style trajectory stays stable because it does not condition on unverified tokens. The right panel tracks training, where accuracy at k drops as k grows, and cross-entropy loss rises. Figure 3 ties the whole Deer workflow together, showing how training sets up the diffusion drafter for long block proposals that the autoregressive model can safely verify. The left panel covers stage 1, where teacher answers get truncated and a separator token marks the boundary, so the diffusion model learns continuation, not full sentence reconstruction. The middle panel shows stage 2, which reweights the masked suffix, so tokens near the prefix matter more. The right panel shows inference, where draft tokens get accepted or rejected one by one. Table 1 makes the speed claim concrete by showing that Deer consistently beats Eagle 3 across coding benchmarks and model sizes. This table shows speedup and tau, where tau is the average accepted draft length, so higher tau usually means fewer verifier interventions. The full grid compares methods across MBPP, Code Alpaca PY, Human Eval, and Live Code Bench. The QN330 BA3B block highlights the biggest gap, with Deer reaching about 4.3 speedup on Human Eval. Table 2 shows that diffusion drafting translates into faster decoding across several target model sizes, mainly because the verifier accepts longer runs of draft tokens. The full table compares speedup and tau, where tau is the average number of accepted draft tokens. In the QN38B block, Deer reaches about 3 times speedup on MBPP. In the QN330 BA3B block, Deer hits about 6.6 tau on Human Eval. Table 4 shows that the diffusion drafter can sustain much longer best-case accepted runs, which matters because longer runs mean fewer costly verification interruptions. The full table reports maximum accepted token length, meaning the longest contiguous draft segment the verifier kept. In the Deer column, the maximum reaches 32 tokens. In the Eagle 3 column, the maximum stays under 10 tokens, even on QN330 BA3B. Table 5 then shows throughput on Human Eval, where tokens per second rise with batch size for Deer. Okay, 2 takeaways stand out. Diffusion drafters can propose long blocks in parallel, and the autoregressive verifier can still stay exact, because the accept-reject step keeps the final distribution lossless. The broader implication is that speculative decoding might get much faster without sacrificing model fidelity, especially at scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.